So welcome to mathematics class, matrices part 9. So in the last class, we have learned how to find adjoint matrix and inverse matrix of 2 by 2 and 3 by 3. So in continuation of the last class, so let us practice some more problems from the exercise. How to find adjoint and inverse. So in the exercise, same exercise 3E, Roman 1, the first question, second bit. So find adjoint and inverse of cos alpha minus sin alpha sin alpha cos alpha. So find adjoint and inverse of this one. So we know how to find adjoint of a 2 by 2 matrix if A is equal to A, B, C, D, then adjoint A is equal to, just interchange these two and AD interchange చేయాలి. A ప్లేస్లో D వస్తుంది, D ప్లేస్లో A వస్తుంది. తర్వాత ఈ BCకి సైన్ చేంజ్ చేయాలి. BCకి సైన్ చేంజ్. BC ఇంటర్చేంజ్ చేయొద్దు, ఓన్లీ సైన్ చేంజ్ చేయాలి. First diagonal elements interchange the elements of first diagonal, that is write D in place of A and A in place of D. Next, the other diagonal, only change the sign for other diagonals. So this is the procedure of writing adjoint of 2 by 2 matrix. So now for the given problem, adjoint of the given problem. So cos alpha, both cos, so interchanging will not change. Rendu cos alpha ఉన్నాయి. And for the minus sin alpha, sign change చేయాలి. Other two diagonal elements of the two diagonal, minus sin alpha will become plus sin alpha. Sin alpha will become minus sin alpha. So this is the adjoint. Now find the determinant. So what is det A? If A is ABCD, so we know det A is equal to AD minus BC. So this is the 2 by 2 matrix determinant of any 2 by 2 matrix. So AD minus, so here the det A, AD minus BC. What is AD? Cos into cos, cos square, cos into cos, cos alpha into cos alpha, that is cos square alpha, minus Sin alpha into minus sin alpha minus sin square alpha. So minus into minus will become plus, that is cos square alpha plus sin square alpha, that is equal to 1. So det A is equal to 1. We know from trigonometry cos square theta plus sin square theta is equal to 1. So the determinant of this matrix is 1. Now its inverse, A inverse is equal to adjoint A by det A. So now A inverse is equal to what is adjoint? Cos alpha sin alpha, cos alpha sin alpha minus sin alpha cos alpha. So this is adjoint. So det is 1 by 1. Det is 1 and you need not write 1 by 1. So this is how we find determinant of 2 by 2 matrix. In the last class also we practiced. So this is the procedure to find 2 by 2 adjoint matrix and inverse. Now let us practice another problem, that is fourth one in your textbook. If A is equal to -1 -2 -2, 2 1 -2, 2 1 -2, 2 -2 1. So if this is the given matrix, then show that A is equal to 3t. A is equal to 3 into A transpose and find A inverse. A is equal to 3 AT అని చూపాలి, తర్వాత A inverse find out చేయాలి. So now first let us find cofactors. Cofactors. So in the first row, now let us find the cofactors, that is CF of first element -1. So let it be A1. So take the 4 elements, -1 ఉన్నటువంటి రో, -1 ఉన్నటువంటి కాలం వదిలిపెట్టి మిగతా 4 1 -2 -2 1 1 -2 -2 1. ఈ దీనికి మైనస్ వస్తుంది, దీనికి మైనస్ వస్తుంది, దీనికి మైనస్ వస్తుంది. ఈ 4 ఎలిమెంట్స్ కోఫాక్టర్స్ రాసేటప్పుడు మైనస్తో ఇంటూ చేయాలి. నౌ లెట్ us ఫైండ్ కోఫాక్టర్ ఆఫ్ -2. Cofactor of -2, cofactor of -2, let us name it. సో దీనికి మైనస్తో ఇంటూ చేయాలి. ఏముంటాయి ఇవి? -2 ఉన్నటువంటి రో, the row in which -2 is there, so eliminate or neglect, and the column in which -2 is there, that is second column. First row second column వదిలిపెడితే 2 -2 2 1 ఎలిమెంట్స్ ఉంటాయి. 2 -2 2 1. సో 2 -2 2 1. Next, cofactor of -2. So third element of A1, let us B1 C1. For -2 third element, the first row third column, eliminate first row third column, then take the remaining 2 1 2 -2 2 1 2 -2. So next, second row elements for R2, cofactor of 2, that is, let us name it as A2. So for this you need to multiply with minus and take the 4 elements. You see, neglect the row in which the element is there, that is neglect R2 second row and neglect the column first column. So R2 C1, neglecting R2 C1, what do you get? -2 -2 -2 -2 1. So these are the elements. You get -2 -2 and -2 1. Then cofactor of second element in second row, that is 1. Name it as A2 B2. So take the 4 elements after neglecting the row and column. సో ఈ 1 ఉన్నటువంటి అంటే మిడిల్ ఎలిమెంట్. సో ఇది సెకండ్ రో మొత్తం వదిలిపెట్టాలి, సెకండ్ కాలం, జస్ట్ లైక్ సెకండ్ రో సెకండ్ కాలం. కార్నర్ ఎలిమెంట్స్ మిగులుతాయి, -1 -2 2 1, -1 -2 2 1. సో ఈ టేకింగ్ సెలెక్టింగ్ ద ఎలిమెంట్స్ ఇస్ వెరీ ఇంపార్టెంట్. -1 -2 2 1. That's why I am repeating. In the last class also we did, but again we are practicing the same problem, finding inverse. Next, cofactor of third element in the second row, that is -2. Let us name it as C2. So for this we need to multiply with minus and take the 4 elements. Look at this, -2, we need to multiply minus for this cofactor. So the row is second row, eliminate the second row and third column. So the element is in third column, second row third column. So eliminating both second row third column, the remaining 4, -1 -2 2 -2, -1 -2 2 -2, -1 -2 and 2 -2. Now cofactors of third row R3, cofactors of R3, So cofactor of first element in R3, మూడవ వరుసలో మొదటి మూలకం 2. Let us name it as A3. So R3, neglect the R3 and C1. ఈ ఎలిమెంట్ R3లో ఉంది, C1లో ఉంది కాబట్టి R3 C3 వదిలిపెడితే ద రిమైనింగ్ -2 -2 1 -2 -2 -2 1 -2. Next, cofactor of second element in third row. So name it as B3. So for this we need to multiply minus. So ఇందులో R3 C2 వదిలిపెడితే -1 -2 -1 -2 2 -2. And cofactor of the last element 1, name it as C3. So ఇది R3 and C3లో ఉంది. R3 C3 వదిలిపెడితే రిమైనింగ్ 4 ఎలిమెంట్స్ -1 -2 2 1 -1 -2 and 2 1 -1 -2 2 1. -1 -2 2 1. Okay. Now let us simplify. First, selecting is very important. After selecting the 4 numbers, then simplification is very easy. So 1 into 1, cross multiplication, -2 -2 plus 4. 1 minus 4 is -3. Now minus of 2 into 1 2, 2 into -2 -4, minus into minus plus 4. 4 plus 2 6 is -6. 2 into -2 -4. 2 into 1 2 is -6. The first row is -3 -6 -6. Cofactor matrix. Cofactor matrix. Let it be as B -3 -6 -6 -3 -6 -6. Next, second row. So minus of -2 into 1 -2 minus, this is formula minus, -2 into -2 plus 4. So -6 into minus, this becomes +6. Next, -1 into -1 -1. 2 into -2 -4 minus plus 4. 4 minus 1 is 3. Minus into minus plus 2. -2 into 2 -4. -4 into minus plus 4. 4 to 6 and minus into 6 -6. So 6 3 minus 6. 6 3 minus 6. The second row cofactor 6 3 minus 6. Now let us find third row cofactors. So minus 2 plus 4 minus into minus. Minus 2 into 1 minus 2 and minus plus 2, that is 6. Next, minus of minus 1 minus 2 plus 2. 2 into minus 2 minus 4 minus into minus plus 4. 4 plus 2 6. 6 into minus minus 6. Minus 1 into 1 minus 1. Minus 4 into minus plus 4, that is 4 minus 1 3. 6 minus 6 3. 6 minus 6 3. So 6 minus 6 3. So this is the cofactor matrix. Now adjoint. Adjoint is the transpose of cofactor matrix. So that is convert the rows into columns. Minus 3 minus 6 minus 6. Write this as column. Minus 3 minus 6 minus 6. అడ్డు వరుసలు నిలువు వరుసలుగా రాయాలి. 6 3 minus 6. 6 3 minus 6. So third row becomes third column. 6 minus 6 3. So this is the adjoint matrix. Let us name it as 1. Adjoint A. Now let us find AT. So find the transpose of the given matrix. Again convert the rows into columns. ఇచ్చినటువంటి matrix లో rows ను columns గా convert చేయాలి. minus 1 minus 2 minus 2. First row will become first column. minus 1 minus 2 minus 2. Then second row 2 1 minus 2. 2 1 minus 2. Second rows become second column. And third row 2 minus 2 1. 2 minus 2 1. So converting the rows into columns is the transpose. AT అవుతుంది. Now find 3AT. Now we have to find 3 into AT. 3 into AT. That is 3 into this matrix 2 2 minus 2 1 minus 2 minus 2 minus 2 1. So multiplying all the elements with 3, we get minus 3 6 6 minus 6 3 minus 6 minus 6 minus 6 3. So this is 3 A dash or AT. So this is, let us name it as 2. So now look at this. 1 and 2 are equal. So from 1 and 2 we get adjoint of A is equal to 3AT. So this is one proof. And next we have to find the inverse matrix also. So for inverse, we need to calculate, we need to find a determinant. Now let us find the determinant, that is A1, A1, B1, B1, and C1, C1. So this is the definition of determinant. So sum of the products of elements with their cofactors. So here det A. So what is A1, B1, C1 are the first row elements in the given matrix. So -1 is A1, -2 is B1, and -2 is C1. So capital A1, capital B1, capital C1 are the cofactors. What are the cofactors of A1 first row? Cofactors of first row: -3, -6, -6. So multiply with cofactors: -3, -6, -6. So this is -3, -6, -6. So -1, -3 plus 3. So -2, -6 plus 12. This is also plus 12. 12 plus 12, 24 plus 3, 27. So this is the determinant is 27. Now we have to find inverse. So what is A inverse? So adjoint A by det A is the formula. So now A inverse. So 1 by adjoint by det can be written as 1 by 27 into adjoint matrix. So what is adjoint matrix? -366, -6, 3, -6, and -6, -6, 3. So this is the inverse of A. So yesterday we practiced how to find inverse and adjoint of 2 by 2 and 3 by 2, and in this also we have practiced how to find adjoint and inverse. So this is adjoint. So det adjoint by det is the inverse. So this is and let us practice another problem from the exercise. So this is from your textbook, same exercise, Roman number 2, second question. This is also important, came in the exam so many times. If 3a is equal to 1 to 2, 2, 1 minus 2, minus 2, 2 minus 1, minus 2, 2 minus 1. If 3 into a is this much, then show that 3a ఈ మాత్రిక అయితే then show that A inverse is equal to AT. A special problem, we have to show that A inverse is equal to AT. So by making use of the definition of A inverse is equal to B if and only if AB is equal to BA is equal to I. So making use of that definition, we prove this one. So as 3a is equal to this one, if you bring 2 this side, so this will give us a is equal to 1 by 3 into 1 to 2, 2 1 minus 2, so minus 2 2 minus 1. This is the a. So now from a you can write at transpose of this one. Convert rows into columns. 1 2 2 as column, 2 1 minus 2, minus 2 2 minus 1. అడ్డు వరుసలు నిలువు వరుసలుగా మార్చితే 80 అవుతుంది. minus 2 2 minus 1. So this is 80. Now let us multiply a with 80. So what is a? 1 2 2, 2 1 minus 2, minus 2 2 minus 1. So this is a, and 80 1 2 minus 2, 2 1 2, and 2 minus 2 minus 1. I am multiplying a with 80. And what is the procedure? Take the rows in first matrix and columns in second matrix. So R1, R2, R3. So in this one, C1 first column, second column, third column. Take the first row and multiply C1, C2, C3. And take the second row, multiply C1, C2, C3. And take the third row, multiply C1, C2, C3. So before that, 1 by 3 into 1 by 3. 1 by 3 into 1 by 3, you will get 1 by 9. So this is equal to a into 80, 1 by 9, and multiply first row into first column. 1 into 1, 1, 2 into 2, 4, 2 into 2, 4. Next, R1 into C2 second column. 1 into 2, 2, 2 into 1, 2, 2 into 2, 2 into minus 2, minus 4. R1 into C3, 1 into minus 2, 2 into 2, 2 into minus 1, minus 2. Second row into first column, 2 into 1, 2, 1 into 2, 2, minus 2 into 2, minus 4. R2 into C2, 2 into 2, 4, 1 into 1, 1, minus 2 minus 2 into minus 2 plus 4. R2 into C3, 2 into 2 minus 4, 1 into 2, 2 minus 2 into minus 1 plus 2. R3 into C1, minus 2 into 1, minus 2, 2 into 2, 4, minus 1 into 2, minus 2. R3 C2, minus 2, 2, minus 4, 2 into 1, 2, minus 1 into minus plus 2. So R3 into C3, minus minus plus, minus 2 plus 4, 2 into 2 plus 4, minus 1 plus 1. Now 2 plus 2, 4 minus 4 will get cancelled. Minus 2, 4 will get cancelled. 4 minus 4 will get cancelled. Minus 4 plus 4 will get cancelled. So all this will get cancelled, and this is after simplifying 1 by 9. This becomes 9 0 0 0 9 0 0 0 9. We get this one, and taking 9 common, taking 9 outside, this becomes 1 0 0 0 1 0 0 0 1. So 9 9 will get cancelled. We get I, that is unit matrix. So here what we get, what we did, A into AT. So A into AT, we are getting 1 I. So let us name it as first equation. Similarly, we can prove, that AT into A is also I. So from 1 and 2, from 1 and 2, we get A into AT is equal to AT into A is equal to I. So this is, we can write this is in the form of AB is equal to BA is equal to I, where B is equal to, I am taking AT as B. AT ni B అనుకుంటే ఇది మనకు AB is equal to BA is equal to I రూపంలో ఉంది. So this implies by definition, this is the definition of inverse. This A inverse is equal to B. Here what is B? That is AT. Therefore, A inverse is equal to AT. A inverse is equal to AT. These two are equal. So this is the proof. So remember this one. Here, don't go for finding inverse. Here the question is, show that A inverse is equal to AT, A transpose. Generally, we try to prove this as finding A inverse. That becomes very lengthy. So remember this one. So for this, we need not find its inverse. By making use of the definition AB is equal to BA is equal to I, we can prove it very easily. So this is the one of the important questions in this chapter. So remember this one. The proof is very interesting. Without finding inverse, we can prove it. So let us practice another question from this. That is fourth one. If AB is equal to I, AB is equal to identity matrix, or PA is equal to identity matrix. Then prove that A is invertible. A is invertible and B is equal to A inverse. B is equal to A inverse. We have to prove B is equal to A inverse or A inverse is equal to B if AB is equal to I and BA is equal to I. Now let us take the given condition. What is given? First one, AB is equal to I. So I am taking the modulus both sides. So this implies determinant properties. I am taking determinant both sides. AB whole determinant is equal to A determinant into B determinant, and this is 1. Determinant of a unit matrix is 1. Now determinant of A, determinant of B, the product is equal to 1. This implies the determinant of A is not equal to 0. So that is det A not equal to 0. That means it is a non-singular matrix. Here A is idi sadharana matrika, non-singular matrix. Now we can prove B is also non-singular. Given another condition, BA is also equal to the identity matrix. Taking the determinant both sides, determinant of BA is equal to determinant of I. So this also determinant of B into determinant of A is equal to 1. You can remember the determinant of I is 1. Determinant of any unit matrix. Determinant of any unit matrix. తత్సమ మాత్రికకు డిటర్మినెంట్ 1 అవుతుంది. Already explained in the previous classes. So I is being unit matrix and its determinant is 1. Now the product of two numbers is 1, then the both of them should not be 0. ఇవి రెండు గుణిస్తే 1 ఎప్పుడు వస్తుందంటే ఇందులో ఏది 0 కావద్దు. సో దిస్ ఇంప్లైస్ the determinant of B not equal to 0. That is det B is not equal to 0. So this implies P is also non-singular matrix. P కూడా సాధారణ మాత్రిక. Both are non-singular matrices. And AB is equal to BA is equal to I, where both A and B are non-singular. So this implies A is invertible. This implies A is, this is the definition, if A and B are both non-singular of same order, then if AB is equal to B is equal to I, then A is invertible, and further A inverse is equal to B, and also A inverse is equal to B, or B is equal to A inverse. So this is the proof for this problem. So very simple, making use of definition, we can prove it. AB is I, BA is I. So making use of this, we have proved that both A and B are non-singular. What is non-singular? If the determinant is not equal to 0, then it is a non-singular. So for both A and B are non-singular, and AB is equal to BA is equal to I, and both A and B are non-singular. So that is invertible. A is invertible. This is the definition of invertible. And also A is invertible and A inverse is equal to B, or B is equal to A inverse. We can write it B is equal to A inverse. So with this, I conclude today's class. So once again, practice some more problems from the textbook and from solved problems in the textbook. They are very easy. If you practice more problems, it becomes more easy. So practice makes man perfect, you know it. So in the case of mathematics, you need to practice more problems. Kevalamu, by simply observing, and it is not enough in mathematics especially. So mathematics is a skill, is an art. So by observing you cannot learn an art. Just like driving, if you want to learn driving, if you observe years together, you cannot learn. If you practice, then only you learn driving or swimming. So just like that, mathematics is also an art. It can be practiced. You cannot learn mathematics by simply being a spectator. ఇది చూస్తే మ్యాథ్స్ వచ్చేది కాదు, చేస్తే వస్తుంది. మీరు చేస్తూ ఉండాలి. అండ్ యూ ప్రాక్టీస్ 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 మోర్ నెంబర్ ఆఫ్ ప్రాబ్లమ్స్, ఇట్ బికమ్స్ ఈజీ ఫర్ యూ. నేను ఖాళీ విని నాకు మ్యాథ్స్ వస్తలేదు అంటే వింటే రాదు. వింటే ఏమొస్తుంది? రాదు. ఇట్ ఈస్ నాట్ ఏ లాంగ్వేజ్, ఇట్ ఈస్ మ్యాథమెటిక్స్ ఈజ్ అన్ ఆర్ట్. సో యూ హ్యావ్ టు ప్రాక్టీస్. ఎవరు ఎక్కువ ప్రాక్టీస్ చేస్తే వాళ్ళు దీంట్లో పర్ఫెక్ట్ అవుతారు. యూ ప్రాక్టీస్ మోర్, యూ విల్ బికమ్ మోర్ పర్ఫెక్ట్. ఓకే, సో థ్యాంక్ యూ ఫర్ వాచింగ్.